Alrighty, another day at Unitech Engineering as a mold making apprentice. I'm Isaac and I work here. Today we're getting into a little bit of manual lathing. As you can see, there is a core sitting on a magnetic chuck, which is clamped by a centering 3-jaw chuck. Almost had a brain fart there. So basically I'm cutting the angle for that core, as you can see, using I just made a custom ground carbide tooltip, and this core is a heat treated 420 stainless steel part, so it's a little hard. And the real challenge with this part was that there's a lot of interrupted cuts with this thing, and when I slow the spindle down, you'll see all the air vents that are going through that are on top of the or on the surface of the angle, as you can see right there. Fitting the ring on there. That's what this cut is for, so that ring, which is a stripper ring, can sit perfectly on top of that angle. But it looks like that ring was a little tight because I wanted the ring to be sliding smoothly on top of the core. Because of those interrupted cuts, the tooltip is wearing kind of fast, so that's why I had to adjust the x-axis there. The reason why there's air vents there is because we tried to make those before we sent it to heat treating, but now I realize that it's probably better to do it after heat treating, even though we have to mill hardened steel, because these interrupted cuts were a little challenging. The way that I had to, so these interrupted cuts, they made a lot of vibration, firstly, and they wore the tool down pretty fast. So the way I fixed that issue is I tried ceramic tips and it didn't really work well, so I tried making a carbide tip with a more pointy tool tip, and that seemed to prevent it from vibrating so much. And it still does wear a little bit, but it's not that bad. Just gotta adjust that the x-axis, and then just gotta keep sharpening the tool once in a while. I think in those 18 cores that I'm doing right now, I sharpened the tool probably a few times, so it's not really that bad. Done with the indicating. That indicator is a dial indicator, and it's a 1/2,000 dial indicator. Can't really tell because the glare from the lamp. The depth of cut that I'm doing there is, the first cut that I do, I like to go a little deep. I like to go about probably 1 to 2 thousandths depth of cut, which is about 2 to 4 thousandths on the dial right there, because the dial is cutting for diameter, not literal amount you moved. being careful with the final pass, because if I just aggressively move that dial, then there's some backlash on the tool. Let's fit it, and nice and smooth. I'm gonna take it off and do my final core. These parts, this tooling here is going to be for caps, and the area it shuts off is where the ring's edge meets the core. So that's why this ring has to be pretty accurate. There can't be any big gaps between that edge and the core, or else, you know, the part's going to flash through, and there's going to be a big piece of plastic flash sticking out on the part. And it can't be too tight, or there's going to be some gulling where the ring and the core meet. The surface is going to rub too much, and there can be some bad gulling. So that's why I gotta get this nice and pretty perfect. The reason why the part looks gray is because it was heat treated. And after heat treating, our heat treater at least, they have a service where they sandblast your parts. And that's what we had. That's what we had done on these parts. There is another way to do this though, where you don't heat treat it. Leave some stock on the part, and you basically cut that stock off after the heat treating to make the surface look nice and shiny. But that is an extra step that we thought might be unnecessary, and you would do that if you want the part to be super accurate, and if there's a lot of warping during the heat treating process. But this is 420 stainless steel, so there's not that much warping. So we decided to just go with sandblasting and just finish the necessary areas like the ring shut off. Alright, I'm done. Finally. Yep, look how that slides. Nice and perfect, no gaps. Time to shut everything off. Prepare to go home. I'm probably like, I'm gonna clean that in the morning. I'm kind of tired right now. Right now it's just me and my uncle at the shop. I do suggest to him once in a while that we should get an assistant, like kind of like a monkey boy, to do all this little cleaning jobs and deliveries and things like that for us, so we can focus on the more important tasks. But you know, he's very old school, wants to do everything yourself kind of mentality, which is great, you know. In this generation, I feel like more of that is needed. But you know, sometimes I feel like it might be a good leverage wise to have someone like that, to hire someone like that. Anyways, I am cleaning the CNC, and that fixture there was for the vents, air vents on the rings. It's not a super sturdy, secure fixture, but it's just air vents on the rings, which those air vents in particular don't need to be super accurate. So that fixture was good enough. Okay, I'm turning off the air. We like to release the air before we shut down the shop, so that just in case water doesn't collect inside, we do have water filters, but just in case, you know. Alrighty, that's the end of the video. We have successfully finished off these cores, and they're almost ready to go to the customer. Just gotta do a few finishing touches. If you need a custom mold and you're looking for vendors, you can give us email or call. It's in the description below, and we will give you a free quote. A disclaimer is our molds are US made and quality, and we don't sell cheap overseas Chinese molds. Thanks for watching.